Hello everyone, welcome back. In today's video, we're going to talk about a platformer game built in p5play. As we've done with the previous week's examples, the idea here is to build a simple little game demo from scratch. And while we're doing this, we're introducing some new concepts we haven't talked about within the p5play game engine. So just before we start, here's basically what we're going to be building this week. I'll show you the completed version. This week we're going to be building a little platformer game. So we have a character that we can control with the arrow keys, and a little bit difficult to talk and play at the same time. This game is actually much harder than it looks. The goal of the game here is to jump on these platforms and make your way up to the top to pick up these gems. Okay? If you fall, you get to either run into these spikes at the bottom, or if you jump off screen, that also takes away 1 life. And you got to collect all 3 gems with your 3 lives that you have available. So we're going to be building this game. And as we go along, the 2 main things we're going to be focusing on this week is going to be talking about sprite sheets. So using a sprite sheet to create all the different animations for our character. And we're also going to be talking about tiles and the camera in p5play. So using the tiles object, we're going to be able to do some rudimentary level design, essentially. And with the camera, as you can see, we'll be able to have a level that is bigger than can fit on our screen, and then use the camera to have it follow our player character. Let's see if I can collect the gem. Yay, I did it. Okay, follow our player character. Okay, so let's dive in. In part 1, we're going to focus on the character itself, and then in the other part, we're going to build the level around it and the various interactions between the player and the level elements. So let's stop the sketch. We're going to make a new sketch here. And we'll just really quickly go ahead and create a p5play game by bringing in the p5play library. We've covered this extensively in other videos, so I'm not going to go over that again. Bringing in the p5play library over here. I'm also going to start off just by including some assets for the game. So I have some files here. These are all Creative Commons license assets from different assets on itch.io. And the links will be included in the final version that's going to be in the comment. Okay? So we're going to bring these assets in. We're going to add files to our sketch. And we're simply going to upload the files to our sketch. So we can see already at a glance here, we have an asset for our platform. We have a sprite sheet for our ninja. We have a little spike graphic. We have a block. We have a little animation for the gems. And we have a font that we're going to use as well. Okay. Let's jump back into our sketch. Now, as we've done in the past, we're going to use a new canvas instead of create canvas, because p5play has its own canvas object. And for this game, we're going to make a 200 by 200 canvas. Okay? And if I just go ahead and run, you can see this is 200 by 200. The reason we're going to do this is because our game is using pixel art. Okay, so all of our assets are fairly small. If we take a look at our block, right, we have a 16 by 16 pixel little block here. We have a same thing with our gem. These are all pretty small. It's meant to be a pixel art game. Same thing with our ninja. These are 24 by 24 animation frames. And we'll use that sprite sheet to create all the different animation states of our ninja. So we want to be working at that kind of pixel art scale. So that means that our game world is going to be 200 by 200. And what we can do with p5play, which is nice, we've done in the other video as well, we can say, let's set it to pixelated. So that means the actual width of the canvas will take up the space that we have available. But as we start to add assets on it, they will get scaled up accordingly. Okay? So that'll make more sense when we start to create the animations for the player. We'll go back and remove pixelated to see what happens. Okay? So now we have a 200 by 200 canvas. The actual size on screen is bigger, but in kind of like world size, we have 200 by 200. Okay? And let's set a slightly darker background here. For this game, we'll go with slate gray. Okay, something a little bit more pleasing to the eye. All right. So step 1 here, we're going to start by, in this video, we're going to build our player character, which means we're going to create a sprite object for our player. Let's call this object Ninja. So we'll make a variable called Ninja to represent our player. And Ninja will be a sprite that we create. So we'll say new sprite. So you can see this sprite looks bigger here because we are in this pixelated world. Okay. We'll create a sprite, and then we will slowly go and start to put in some attributes on our sprite. Okay. So first thing is let's give our player dimensions. Okay. So we'll say the actually we're gonna load the sprite sheet first. Okay. So this is gonna be our ninja, and of course we have some work to do here in terms of animating and setting up objects. So let's start off by bringing in our sprite sheet. Okay. So sprite sheets are a very convenient way to bring in lots of animations packaged into one file. Let's take another peek at our ninja.png here. We can see each row has an animation sequence that reflects a different action. So we have 8 possible actions altogether, some of them shorter than others, starting with the idle state at the beginning. Then we have a run animation, kind of a dash animation, and so on and so forth. Okay. So what we're going to do is we're going to create a sprite sheet, and we'll say let ninja, let's call this sprites. Okay. And we're also going to create an array that's going to contain the definition of all of these animations. Okay, so we're going to tell the sprite sheet, okay, on the first row, we're going to have an animation and we're going to give it a name. We'll say how many frames does it have. We have to provide all of this data to p5play in order for p5play to be able to load the sprite sheet the way we want it to. Okay? So we'll have ninja sprites, and we're also going to have a variable. Let's call it changeAnis for animations. And the idea here is that we're going to have an object. Okay? And inside of this object, we're going to define a list of animations. Okay? So for example, we're going to start off with the idle animation. Okay? So we'll say idle is going to be in our sprite sheet. Idle is going to be row 0, and it's going to have 6 frames. Okay? So if we go back to our Ninja PNG, we're going to say idle, right, is the first row, and it has 1, 2, 3, 4, 5, 6 frames of animation. Okay? Go back to sketch here. Then we can put a comma. So this is the first element in our changeAnis, and we're using this. This is going to become the name of that particular animation, so that we can refer to it by name, and we'll be able to change between different animations for our player. The next one is we have a running animation. This one is going to be the next row over, and also has 6 frames. Okay? And then separate with a comma. So this data structure can be a little bit confusing to look at, but if we break it down, right, we can see we have an object over here, and then we have a name for the animation, and then the value is another object that contains rows and frames. Okay? So we're going to follow the same pattern for all of them. Now we have run, we have a dash animation, that's the next one in my sequence, and I'm just doing them in order just because it's simpler. Okay? The dash animation is a little bit shorter. Again, going back here, we can see down to row number 2, we have 5 frames all the way down to the bottom that only has 4 frames. Okay? So let's put in our different animations. If you don't feel like typing this out, you could just copy and paste this block from the completed example. It's fairly error prone. Okay? So after the dash, we have a jump animation. Then we have a slide animation. This is on row 4, and it has also 5 frames. And then you got to be careful with those commas here. We want to make sure we have a comma separating all the different animation definitions that we're putting in. And I kind of don't feel like typing the other 2, so I'm going to just go ahead and grab them from over here and copy and paste them. Okay, so I've added a trip animation, so row 6, 5 frames, and finally we have a shorter animation for when the player lands. That one is on row 7 and only has 4 frames. Okay? And then we're going to get rid of this white space, and that kind of closes the definition of our sprite sheet. Okay? So we're going to load in a sprite sheet, and then this is going to be all of each row of the sprite sheet. We have to say how many frames do you have and give a name to that particular animation. All right, now the sprite sheet itself is an image, so let's go and implement preload. We're going to say ninja sprites equals load image. ninja.png. Oops, ninja. So we're going to load this in preload. Again, we want to make sure our image is available. Let's put in some little visual separators already, because this code is going to get kind of long as we develop it. So again, this is optional, just something I like to do. We're going to load our Ninja sprites in preload, and then we're going to go and create, assign this sprite sheet. We'll say ninja.spritesheet equals ninja sprites. Okay. So we're going to assign the sprite sheet to our Ninja object. Okay. Do I have a typo in my file name? No. Maybe I should save this. Let's see what happens. Ninja animation. Save it. That good old p5.js error. This file does exist. It is there, but for some reason, p5.js struggled. That happens in the previous video as well. My solution to that is just to make a duplicate. We'll make a copy of this this sketch, and it should now be able to find the image. Okay, now there's no more error. So when p5.js is giving you issues with your file names and you confirm that the file does exist, it is there. It's I find just making a copy of the sketch usually just solves the problem. Okay? So let's rename this to let's call it Spritesheet. Okay? So, and that's going to be the example we post later. Okay, so going back to setup here, we're going to set our, so we've made a Ninja sprite. We're going to set Spritesheet to Ninja sprites, and then we're going to start kind of configuring our Ninja object. Now that we've assigned a Spritesheet, we can say we'll say Ninja. We're going to add all the animations that we defined at the beginning inside this changeAni's variable. Okay. Sweet. Now you can see our object has disappeared. Okay, so that's totally normal. What we're going to do then is let's go and set the animation that we want to play. We're going to say changeAni idle, and we may also have to define. Oh, there we go. Okay. So now we can see it's actually playing the whole sprite sheet. Okay, so we're going to go and add a little bit of details here. So before we add these animations, we're going to say the animation, the dimension of each frame inside the animation. We haven't specified that here at the beginning. We just said this is the row and the number of frames. We have to tell our object what's the dimension of these animations. Okay, so we'll say the width. I know because I've checked the file first. Our animation sequence, each individual animation is 24 by 24 pixels. Okay. All right, there we go. So this is now our animation. And if we go on here and say all sprites.debug equals true, we'll be able to see that this is now the actual size of our object. Okay. It's a little bit bigger than the animation itself, because this is 24 by 24. Okay. So what we could do is make this a little bit tighter around, make the collision box a little bit tighter around our Ninja. We're going to say, let's set the width of our character to 10. Okay. And let's set the height to something like 14. Okay. So now this collision box is a little bit tighter to the Ninja itself. It is offset, however, right? So because we've just shrunk it, we want it to be a little bit offset more towards the bottom of the initial collider. So the other thing we could do also is we can add an offset to this animation box. So we'll say anis.offset.y equals -4. Okay, so that's going to take our animation and move it up by 4 pixels, so that now it fits a little bit tighter inside our little collision space here. Okay. All right. So this is going to help just make sure that when we do collisions later on with objects in the game, our collision box is not bigger than the actual visuals that we see. Okay, and we have our little headband flipping to the wind here, but we're going to leave it as is. Okay. All right. So play. So here we're back to our just our animation. So what we can do now is we can use changeAni whenever we want to change which animation is being displayed. For example, if I go to my run animation, now we'll have a character running. We can cycle through them really quickly here. Let's see, what were the names of all the different ones? We had dash. So dash looks like this. We had slide. Slide looks like this. Pretty slick. We had a jump animation. So jump looks like this. When the character is in the air, we want to play the jump animation. And we have a trip animation when the character is just like falling down and hitting their face on the ground. And we have a landing animation that happens when the character should like land on the ground. It gets a little bit squished. I also had a fall animation. This is the character kind of falling down. Okay. Wait, there's no animation named fall. 1, 2, 3, 4, 5, 6, 7. Oh, we forgot one. So after jump, actually, after jump, we needed to put a fall animation. Okay. Fall is meant to be on row 4. That means slide. Sorry about that. Slide is actually on row 5. Yeah. So I should have probably copied and pasted that from the beginning, but here we are. So fall is actually meant to be on row 4, and it has 5 frames as well. Okay, so I have 8 animations. Now we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and looking at my rows here, they're not in the correct order. Perfect. So this is the fall animation. Excellent. Okay, so let's go back to idle as our default animation. Okay, just our character being idle. And we're now going to work on adding some controls to our player. Okay, so now that we've loaded our sprite object, we've attached a sprite sheet to it, we have animations we can change. Let's add controls to our ninja so we can run around, we can jump. Okay? So we're going to use the keys for our control scheme here. And in order for us to be able to test this out, it would be nice if we had some kind of ground for a character to fall onto so we can test running left to right and jumping as well. Okay. So let's add for that purpose at the beginning here. I'm going to make an object here called the ground. Okay, and after we can build it first. Actually, let's go. We'll say ground. Okay, so ground is just going to be a sprite that we make that is going to be static, and it's going to allow us to have something that we can use as a placeholder until we create the more elaborate level with the tiles. Okay. So ground, we'll say new sprite, and let's make this sprite, we'll say we're going to center it here. We can put attributes in the constructor. This is X, this is Y. So let's move it down a little bit. Let's make it double the width of our screen, make sure it's super long, and we'll make it 20 pixels tall. So this is going to be our ground. And let's set the collider to, oh, oops, not a comma here. This should have been flat like this. There we go. And let's set a static collider, okay? Because the other thing we're going to do is we're going to add gravity to our world. Okay, we'll say put in some gravity on the y-axis. Let's go with 10. So if everything falls down here, we want to be able to have our ground collider be static so it doesn't fall. Okay. All right, so now we have a floor that our little ninja character can stand on, and we can start to think about programming the motion of our character. So we're going to jump into draw here, and we're going to start looking at the key presses and animating our character by changing its velocity, changing its animation states. Okay, so let's start off by just doing the left and right animation. Okay, so we'll say if, we'll look at our keyboard object, and if we're pressing, let's start with the left key. If we're pressing the left key, okay, what we want to happen is first of all, we want our ninja animation, we want to change it to run. Okay, so if I hit play here, now if I press my left key, we can see the animations change to run. We want to set the velocity of our character. We're going to say go minus 1.5 on the x-axis. So if I press left here, You can see the character is now going minus 1.5 on the x-axis, and we're falling off. And let's also mirror along the x-axis. We want to be able to flip the animation. Okay? So now I'm going to the left. All right. Let's put another statement here. We'll say if we're pressing the right key. Put else if. Okay? If we're pressing the right key, we're going to do the opposite. Okay? So we want to do the same sequence over here, copy and paste, except the velocity x will be 1.5. We want it to be positive, so we can be walking right. And we're going to set mirror x to false. Cool. So now we have our character. We can run left and right. Okay? Now what happens if I release the left and right key? Okay, it looks like it's still, our character is still running. So what we'll do is we'll add an else at the end of this block, and we'll say if we're not pressing the left or the right key, we're going to simply change. We're going to change the animation of our character to idle. Cool. All right. Nice. So now if I release the key, right, we change the animation to idle. The other thing we can notice is that there's a little bit of a sliding that happens. So we can also go ahead and we're going to set the velocity x. We'll set it to 0 so that when we release the running key, our character stops right away. Okay. Cool. So this is, let's put a comment here. So we're doing here the player controls. So we have left, right, movement, and idle. Okay. So essentially building our character behaviors or character animations is going to be looking at all the other different keys that we can press and thinking about the sequencing of these animation changes. Okay? So for example, if we wanted to be able to jump, okay, we're going to add another if statement. Okay, let's do it before. We're going to say if keyboard presses up. So notice I'm not using pressing, right? Pressing means when you're holding a key down. Presses is when you press a key. So for jumping, it makes sense. We want to be able to just press once and then be able to jump. We're going to say, okay, we're going to say up, or we can also do, we'll say two options for jumping. Let's say up or space. Okay? So we can either use the arrow keys and the up key, or we can use the left and right and the space key, depending on what's more comfortable for the player. So if that happens, let's say we wanted to jump. What that means is we're going to set the velocity of our character. When we jump, we're going to set it to a negative number on the y-axis. We'll say your y velocity, let's go with -4 for this jump, is going to be equal to 4. So now if I press the up key, we have a jump that we can do. And yeah, there we go. And our character falls back down automatically because we have gravity enabled, right? So as we add gravity, the velocity of our character is going to eventually become positive again. In addition to this, let's also change the animation. We'll say change the animation to jumping. Okay. Now, interestingly here, we don't get to see our jump animation because we are pressing some keys here on the keyboard, and we've built a separate if statement. Okay, so that's what I meant by sequencing. It means that this is going to change the animation to jump. Okay, but this is going to bring it back to idle here, regardless of what we do. Okay, now we do want to be able to kind of do this running in the air. I think it looks kind of cool. Okay, so oh no, our character can rotate. We don't want that. Let's go and fix that before we do anything else. We're going to say ninja dot rotation lock equals true. Okay. We don't want rotation. And we want to be able to say, we want to be able to jump. Okay. But we don't want to go to idle while our velocity is negative. Okay, so here we could put a little if statement. We could say if, oops, I accidentally pressed an insert key. We'll say if ninja.velocity.y is negative, or we'll only set idle if our velocity is greater than 0 on the y-axis. Okay. So now you can see that I can jump. I can see my jump animation, and I go back to idle when it falls back down. Okay. So there's a little bit of trial and error involved in building these kind of character animation frameworks, and you got to be careful about how you sequence your if statements and so on. So you know, just experiment, try different things, and don't be afraid to change the order of stuff if it's not doing exactly what you want. Now you may notice as I jump around, we can see there's like these two little, it's hard to see, there's two little pixels here. Oh, I can also double jump, we'll fix that in a bit. There's these two little pixels that appear, okay? Sometimes the animations can get a little bit glitchy, and what we're going to do is we're going to go at the beginning of our code, and we're going to set a value called pixelPerfect, okay? We're going to say all sprites, so that's going to affect all sprites in the game. We'll say pixelPerfect equals true. Okay. And that should fix the weird glitches we get with our animation. Okay. In other words, now this is forcing p5play to use always integers for the positions and the just so that locations are always integer values because we're in this pixelated world. Okay. While we're up here, by the way, this is a good time also to point out what happens if we do not put pixelated, right? So our 200 by 200 canvas, this is what happens, right? So this is the size that we're programming our game at because our assets are so tiny, right? But if we want to be able to scale it up and fill the screen, if we put pixelated, this is exactly what it will do. It will scale everything up, but every coordinate is still relative to this 200 by 200 world size. Okay? So just wanted to point that out. Okay, let's jump back into our player controls here. Now, you may notice one thing that happens is that I can always jump, okay, regardless of what's happening to the player. If I keep pressing spacebar, I can just jump. Maybe that makes sense for the game you're building, but for my game, I want to be able to only jump when the player is actually touching the ground. Okay, so I cannot do these multiple jumps all the time. You know, we're a ninja, but still, we're not that awesome. So let's add a little bit of code here that's going to check. Okay, before we jump, before we're allowed to jump, let's check if the player, if the ninja overlaps. So if the ninja is overlapping with the ground. Okay. In other words, we only want to, let's tidy the code here. So we only want to be able to jump if the ninja is overlapping with the ground. Oh. Let's put collides. I'm not going to use overlap because that means we can go through and jump down. Okay. Now notice if we try to do this, this is actually not going to work, even though counterintuitively it should. Okay. The reason for that is that as our sprites collide with the ground, there's always a little bit of bounciness that occurs. Okay. And we want to be able to test for overlap. As soon as we touch the ground, we want to be able to jump. But if we do overlap, it means those two objects are no longer colliding, and then we're going to just fall through. Okay. So the way we're going to resolve this this problem, this challenge, is we're going to add a sprite to our game that we're going to use as a sensor, essentially. Okay. And this little sensor is going to be an invisible sprite that we put that's going to sit right there at the bottom of our player. This sprite is not going to have any collider attached to it, so it's not going to affect collisions, but it's going to allow us to check for overlap with things like the ground and eventually our blocks and our platforms without having to use our ninja sprite itself. Okay? So in other words, rather than use the object itself to check if it collects with the ground, we're going to add a little hidden object at the beginning that we're used as basically like as a pressure plate or a sensor. So here's what that looks like. We're going to go to the top here, and let's make a variable here. We're going to call it ninja sensor. Okay. And in setup, we are going to go and create this sensor. It's going to be just another regular sprite. Okay. So after we make our ninja, let's call this ninja sensor. So this is going to be a sprite. Okay. And its X location to begin with, we'll make it the same as wherever we put the ninja. Its Y location the same. And we are going to use something called a joint to get those two sprites to be to kind of stick together and always follow each other in the game. Okay? Ninja sensor. We're going to make this into just a small little object. Oh, typo here. So a 12 by 6 little box. Okay, so it's going to be a tiny little box that sits below our ninja. We're going to set its collider type to none. We don't actually want it to interact with the game objects. We only want to be able to check for overlaps with that that object. And here we're going to do something. We're going to create a new glue joint. Okay? So joints are ways that we can take two objects in p5play and have them kind of connected to one another in different interesting ways. Okay? Let's take a little detour here to the p5play website. There's a section on joints. So we're only touching briefly onto joints in this example. We're going to make something called a glue joints, which is basically allows you to get two sprites to be glued together. There's also fun joints like distance joints that allow you to enforce a certain distance between two objects. A wheel joint that allows you to create basically like wheels of a car. Okay, something that's going to rotate, but that's going to be attached to another another object. You can have a hinge joint and also a slider joint. Okay, so these are the different types. Today we're going to use the glue joint to take our ninja sensor, which will be, let's look at it here. Let me run the code. I forgot new sprite here, my bad. Let's run the code. So here we have this is going to be our sensor. Okay, this little object here, we want to glue it to the bottom of our player. So let's go and say new glue joint. We'll say glue joint between the ninja and the ninja sensor. Okay. And actually, let's move this down a little bit. We're going to add half the ninja height to the position of our sensor so that it's sitting down at the bottom over here. Okay. And this is now the object we're going to use to see if we overlap with the ground. Okay. So instead of checking for if our ninja itself collides with the ground, we're going to say ninja sensor overlapping ground. So as long as we're overlapping with the ground, now we're able to jump. Okay. So this works much better than trying to compare the sprite itself with the platform or the ground or whatever object you're trying to collide with. It also kind of gets rid of the issue where sometimes if you try to do this with the sprite itself, there's going to be some bounciness, right? Just because of the physics engine, because of the collisions, it causes the sprite to bounce back up. And this way we don't have that issue because the sensor doesn't have any collider on it. We're only using it as basically as a sensor, as a way to test if this is touching something else. Okay, and now it's clearly touching and we're allowed to jump. And if I press space multiple times, you can see that I can't double jump. Okay. Now, obviously this is looking very ugly, having this little box over here. So this is not a problem. We're going to say ninja sensor dot visible equals false. We'll just say, don't draw this sensor. Now it's disappeared. Okay. And then we can still see the joint. The joint is that little gray thing on the bottom of our ninja. We also want to make that invisible. So let's take our joint we just made. Let's put it into a temporary variable. And we're going to say j.visible equals false as well. So this is going to get rid of the little gray dot that we saw at the bottom. This is what happens when the joint is visible. So now we can't see our sensor, but it's still there, and we're using it to detect if our player is touching other objects, basically with its feet, instead of the whole body of the sprite. Now we're able to run, and we can jump. We have our jump animation that gets overridden. If I jump and press left, we can do this kind of air running animation. Pretty cool. Okay. All right. Now, let's just really quickly add a little bit more detail here to our character because we have a few more animations that we can put in. Okay. We have an animation for when the character is falling. So we could say if down here, fall animation, we could say if the velocity y of our ninja is greater than 0. Okay. So this would change it to idle over here. If it's greater than 0, but if we're velocity y is greater than 0, we're going to say ninja dot Ani changeAni equals fall. Okay. Let's see what that looks like. Interesting. So this is not resetting it back to idle because of the else here. So let's not put that in here. We're going to say let's put an if here. So how would I get the fall to display? Ninja velocity y greater than 0. So that means we're falling down. If we're falling down, we want to change to idle, but only when our velocity y is now equal to 0. So let's say if we're equal to 0, we're going to go idle, and else if greater than 0, we'll say ninja.changeAni fall. So if we have a velocity y that's positive, we want to be able to fall. And then when we go back down, our velocity is now equal to 0 at some point, and we go back to our idle animation. Cool. All right. We also have in our animations, we have a dash or a slide. So let's use that to give our character a little bit of a boost here. So we could say if after we do this this whole left and right motion, if we press the shift key, okay, this is going to be our slide animation. We're going to give a speed boost, okay, and we'll say our velocity x. Let's multiply it by 2 temporarily. So if we look at what that looks like, if I run and press shift, you can see that I can go quicker. And let's change the animation when that occurs. Okay, we're going to say ninja.changeAni. We're going to go to slide. So now we can kind of slide quickly when we press shift. We can jump. We can also do this in the air. That's fine. Looks kind of cool. And yeah, we can jump again. Awesome. We have other animations in our animation sprite sequence that we could decide to use as well. Like for example, we could also add some things to our player control scheme that don't really do anything in particular in the game, but just because we have the animations. For example, if I press the down key, we're gonna get our player to change its animation to the trip animation. So now I can press down, and our player is just like, if we're getting frustrated, we can fall down. Okay, it doesn't really do anything in the game, but we can do that if we want. Now notice by default the animations are always looping. Okay, so once you change to an animation, it's looping. It's doing its looping state. This is something we don't have. We can also change as well. So if we go onto our ninja here, we could say after we had the animations, we can access those animations using the animations object that's inside our ninja. And we could say the fall animation, we're going to set the looping value for our fall animation to, or to a trip, sorry. We're going to set that to no loop. Okay, so we'll say animations trip. This is the one that we're using right now. So that if I press down, our character can just fall down and it's not going to loop automatically. Okay, so there's a lot of control you can have on these animations. Some of them you can play them back in reverse. You can dig into this a little bit if you're interested. Once you've loaded animations, they can be customized. You can change the playback speed. All kinds of customization options are available. Okay. All right. So I'm pretty happy with this, where this character landed over here. We could also add, after we jump here, maybe we'll add another if. Let's see if that's going to work. We'll say ninja sensor. The second that we overlap with the ground, let's see if we could change the animation to the land animation, maybe. So that we get to see like there's a little bit of a bumpiness that occurs. Boom, and then our character stays there. Okay. All right. So this is how we can take a sprite sheet, load the sprite sheet with all of the definition of what's contained in the sprite sheet, where we have one row. Each row is its own animation sequence. Right? Then we can load these animation sequences, give them names. Right? We define the names here and the data in the beginning. And then once we have these animation names, we can trigger them by using the changeAni function. And we can combine that with the keyboard input to start to build some really nice interactivity for our character, with some, kind of careful sequencing here to make sure we don't overwrite certain animations at certain times. So we can do this with a little bit of trial and error. We can really quickly get to some pretty satisfying control schemes here and animations. Okay? The other thing we did in today's video is we also added a sensor object, right? Our sensor is used to create a little bit more robust of a floor detection here, so that as soon as we hit the ground, we can jump right away. There's no bounciness, and this allows us to still collide with the ground without, we can use the overlapping with the ground instead of collide with the sensor, because the sensor doesn't have its own physics. So that creates a much more responsive animation. All right, so now that we have a character, in the next video, we're going to build a level around it. We'll leave it at that for this first demo, and I'll see you in the next one. We're going to talk about using tiles to replace this basic ground layer here with a much more detailed level. I'll see you there.